Welcome to another episode of Radio Signals. My name is Mark, and my call sign is N9WIB. This is the Technician License Series, Lecture Number 14, Digital Communication Modes. To start the presentation, we're going to cover the general concept of digital communications. What is or what are digital communication protocols? Also, we'll cover various digital modes that are used for keyboard-to-keyboard communication, and then we will review WinLink email, and finally end with VHF and UHF FM voice digital modes. The earliest form of digital communication can be thought of as Morse code, or CW. This is essentially turning a radio signal on or off to represent dits and das, or dots and dashes. Digital communication nowadays consists of computer-to-computer communications, or keyboard-to-keyboard communication. A lot of digital communication, the more modern digital communication, involves error checking of signals going back and forth. So you're not just getting gibberish going back and forth on your computer screen, but the actual packets are checked for errors going from the transmitting to receiving station, and the receiving station will go back and ask the transmitting station to send the message again if there is an error that is found. Digital communication is also useful for weak signal propagation. The signals can actually go farther and propagate farther with digital communication in areas where there are very high noise ratios. The digital communication also offers automatic signal reports in the form of a signal-to-noise ratio. It also has the benefit of posting other data besides text, such as GPS position and weather data. Before we get into digital communication, we should review some fundamentals for computer science and data structure in general. So data consists of bits and bytes. Binary data is essentially either a signal that's on or off. A 1 represents a signal that's true, and 0 represents a signal that's false. 1 represents a signal that's on, or a positive voltage, and 0 represents a signal that's off, or 0 voltage. 1 bit represents either a 1 or a 0 in binary. So 1 bit of information is either a 1 or a 0. 1 byte of information, or a byte spelled B-Y-T-E, is a collection of 8 bits. And 1 byte can typically store 1 character. So 8 bits can represent 1 character, such as an A, a B, or a single integer value. Baudot was one of the original coding systems. The Baudot code consisted of 5 bits, or 5 placeholders. There could be variable combinations for each placeholder depending on the number or character that needed to be represented. For example, early on, the code may have been represented in cards that had punch holes in them. The letter A could be represented by 2 holes that were punched in the 1 and 2 position. The letter B could be represented by holes that were punched in the 1, 4, and 5 position, with the others left unpunched. The baud system was derived from the Baudot code. The baud is expressed as symbols per second, and it is a rate of data transfer. So, for example, a 300 baud modem will transfer 300 symbols per second. This is a perfect example of how the old methods of communication originally began. Other methods of data transfer or representing speeds include BPS, or bits per second. Bits per second is not baud. In the Baudot system, there are 5 potential bits in each section representing a number or character. Therefore, bits per second is not equivalent to baud. One of the earliest forms of keyboard-to-keyboard communication, or person-to-person communication over the computer, was something called RTTY, or pronounced RTTY. This is radio teletype, and it is one of the oldest digital modes. It is essentially a keyboard-to-keyboard emulated text conversion. It uses the lower sideband and the Baudot code. This has no error correction, so whatever you're typing on one end, if for some reason your signal degrades, there's going to be a bunch of gibberish that appears on the opposite end of the conversation. Only text and numbers can be sent, and the transfer rate is most commonly at 45 baud. Packet radio is also another mode of digital communication. It is most common on VHF, but can also be found on HF. It uses something called FSK, or frequency shift keying. It can be a form of keyboard-to-keyboard communication. Text is typed on one computer terminal, and that computer terminal is interfaced to something called a TNC, or Terminal Node Controller. The Terminal Node Controller organizes that information into something called packets, and each packet contains a header, the data, and a checksum. The header contains information about the packet and call sign of the destination station. So packets can be thought of as just smaller amounts of information. Let's say you wanted to transfer the contents of a chapter of a book over the airwaves to your friend's computer in TNC. You wouldn't do that by transmitting the whole chapter all at once. That chapter would be broken down into packets of information, and those packets of information could be represented by maybe paragraphs within that chapter. So each paragraph would represent a packet. However, that packet has more information than just the data. It contains the destination of where that packet needs to go, and it also contains something else called a checksum. That checksum essentially allows for error detection. So if the receiving station has a checksum that doesn't match the original one that is sent with the original message, it says, hold on a minute, something must have gone wrong. That message, you need to resend that message because something must have corrupted. There could have been static or poor propagation. Something happened to that packet of information that caused it to degrade and contain errors. So can you please resend that information? And that is the ARQ, or automatic repeat request. The TNC processes the keyboard input into packets and toggles transmit on the transceiver. So when you type a message, it will go from your computer to the TNC. The TNC will convert that information into packets and then tell your radio, okay, it's time to transmit, and your radio will transmit that packet of information through the airwaves to your friend's radio, which will receive the packet of information, send it to their terminal node controller, which will decode the signal from the receiver into data that's human readable for your computer screen. Packet radio transmission rate typically ranges from 1200 to 9600 baud. And as we remember, baud is symbols per second. So that's a rate of 1200 to 9600 symbols per second. APRS, or the Automatic Packet Reporting System, is essentially packet radio on steroids. It has the benefit of packet radio and being associated with the TNC, and some radios actually have the TNC built into them, as well as handheld transceivers may actually have a terminal node controller built into the radio itself. But it associates packet radio with a map, which exponentially increases its value. So stations can be displayed as fixed stations, or you can actually display mobile stations, because APRS can be interfaced to a global positioning system and get real-time location data that is displayed on a map. So you can have a moving car, truck, or bicycle, or even yourself walking down the street with a handheld transceiver that has APRS incorporated into it. It supports messaging, it supports weather reporting, and also, as I mentioned, GPS location. So these stations can be utilized and display real-time weather information on a map. It could also be beneficial by being able to message from one station to many stations. So if you want information to be sent out to a very large group, as an example, you can use this for emergency communications. You can use this in a race or marathon, or you can use this just to report your weather data from your station to the other stations in the region, or you also have the ability for APRS to be incorporated into the internet, and the information can be uploaded into a graphical environment that displays the information throughout the United States. In North America, the operating frequency for APRS is 144.39, and this will vary for different countries in Europe and South America. APRS supports digipeating or relaying of messages to other stations for greater communication distance. As I mentioned before, your packet stations can act as nodes. So your APRS station can actually send your the data that you want to send or message you want to send through several different stations or digipeaters to reach its final destination, which may be well out of your immediate communication range. This is a map of various APRS stations in the Chicago area, and you can see some are just regular houses and some are transmitting weather data with the letters WX written on them in a blue circle. Others are designated as digipeaters with the word D or letter D. And you can even see a track of a car down in the south central portion of the map near Oak Brook and Hinsdale. You can actually see the track that the car with APRS took that drove through the Chicago suburbs. Now we'll get into various HF digital forms of communication. The first is called PSK31, or phase shift keying, and given the name, this occurs at 31 bits per second. It is keyboard-to-keyboard communication on HF. It is a good conversational mode, meaning you can type text back and forth to each other, and it has very good weak signal performance. So on HF frequencies, when you think your voice isn't going to make it that far because of propagation, PSK31 may be a good digital option to transmit text back and forth between a station you may not be able to reach through single sideband. The computer is hooked up to your sound card, and your sound card is hooked up to your radio, and that's all you need. So this is a good method of transmitting information back and forth on HF frequencies between stations in text format through digital mode. And another benefit is that the bandwidth is very narrow at 31 hertz. Other modes of digital communication, such as the WSJT suite of software modules. This is the weak signal digital communication open source software. It was developed by Joe Taylor, K1JT, who's an astrophysicist and a Nobel Prize winner. Other forms within that suite include JT4, JT65, are designed for things like EME or Earth-Moon-Earth or moon bounce on VHF and UHF frequencies, not HF. You can also operate modes under the same suite, such as MSK 144, which is meteor scatter. So you can use this mode to transmit your signal and scatter your signal back to Earth off the tail of a meteor, or the ionization that occurs when the meteor enters the atmosphere. Other modes include FT4 and FT8, which are normal propagation modes on HF frequency. They are semi-automated digital short communication. This is not a conversational mode. This is not something where you're going to rag chew on FT4 or FT8. These are very brief, semi-automated direct messages to other stations that can hear you, consisting of your call sign, time of transmission, and a very, very small amount of other information back and forth. It's kind of like, hello, how are you? And here's my station information. And then you move on. It's good for DX and weak signal propagation. The information is sent in 15-second data blocks or packets in a sense, and it also uses error correction. So it will resend the information if an error is detected in the transmission, which is great on HF frequencies. Whisper is another low weak signal propagation mode. It is used for determining propagation conditions. It is not necessarily communications mode. You're not going to have a conversation on Whisper, but it's used for determining how far your signal can propagate. It is used with low power. Essentially your call sign, grid location, and transmit power are transmitted and received by another station. That station isn't going to communicate back to you. It is in essence a one-way form of communication. And once that station receives your information, that station is connected to the internet, which will post your signal report location and information on a map to the internet. And you can find a whole bunch of Whisper stations on whispernet.org. And this is the map of WhisperNet. So you can see that there are a huge amount of stations that you can actively see on various bands, 40 meters, 80 meters, 20 meters, and you can see how far your signal is actually going to propagate by transmitting on Whisper and then referencing the map on whisper.org, whispernet.org. JS8 Call is another digital mode. This is a very good conversational mode, so it enables text keyboard text communication between amateur radio operators. It was developed by Jordan Shear, KN4CRD, and JS8 Call is essentially the software that runs JS8 digital mode. Again, it's good keyboard-to-keyboard messaging. It has weak signal HF digital communication, so when your voice or single sideband, you're not sure that's going to get through because conditions are poor or the station is far away, this has a greater chance of getting the information across than single sideband does for voice. It acts by breaking up messaging into 60 to 30-second transmission windows, depending if you have it on fast mode or slow mode. And if you have it on fast mode or slow mode, that's also going to determine how far the signal can get. It also supports stored messaging and also relays. And of course, it involves error checking, especially useful for the HF world. Another way of communicating digitally through amateur radio is by email using something called WinLink. But before we can introduce the concept of WinLink, we have to cover what a gateway is. Gateways connect amateur radio stations to the internet. So a repeater may use a gateway for digital modes to allow amateur radio stations to connect to other VHF, UHF stations across the world through the internet. For an example, in Wisconsin, we have something called WeCom, and repeaters are set up in various locations throughout the state, and you have the ability to communicate through VHF to transmit to that repeater. And your signal is not only broadcast on that, or it's not only transmitted on that repeater, but it is sent through the internet to other connected repeaters throughout the state. And your message is relayed and retransmitted through all those repeaters throughout the state. So those repeaters are functioning by utilizing a gateway to facilitate statewide VHF communication. WinLink is a worldwide system for sending and receiving email via the radio. It's not just used by ham radio operators, but it could be used by government agencies and also the Maritime Service. It is used by hams for regular amateur use and for emergency communication. WinLink can be operated on VHF, UHF, and also HF frequencies. You can transmit email peer-to-peer or person-to-person, so P2P. You can send email directly between two radio stations and computers. So if you're close by, or if you want to communicate regionally on an HF station, you can do so and transmit email directly. You can also transmit through something called, or send email through something called WL2K. The email originates on your computer and is transmitted by your radio to something called an RMS. And an RMS is a radio messaging server, which receives your your radio frequency and functions as a gateway, routing your message to the WinLink CMS email service or common message server. So the RMS, radio messaging server, receives your RF transmission, receives your data RF transmission, and sends that data or packet of information through the internet, through a gateway, and then sends that to the common message server, which stores the information or stores your email for later retrieval. The CMS or common message server routes the email to another RMS and back to the destination station. So you're going from your radio transmitting your email message through in digital format to an RMS server, which relays that piece of digital information to a CMS email server, and the CMS email server routes that email to another RMS, which takes it in digital format, retransmits it over the airwaves back to the intended station that you sent the email to. You could also use something called MPS. If the internet or all CMS servers are down, the messages may be transmitted only by radio frequency. So you don't necessarily need to go through a gateway. But you do have to have relay stations or intermediate amateur radio stations called message pickup stations within the path between you and the intended destination for the message. The message is relayed between multiple amateur radio stations without going through the internet gateway in an MPS system. Different modes of WinLink operation. You can use it on VHF. And this uses a TNC and the Telnet operation or a Telnet service. You could use it on HF through Pactor hardware. This is a higher end TNC that is fast and more expensive. Or you could also use it through HF through Winmore software, through Winmore, which is software-based terminal control TNC emulation, and it's slower than Pactor. Or you can use it through post office that communicates through a local area network or mesh network through a Wi-Fi router. So many of us are used to communicating by handheld transceivers or handy-talkies or mobile communications through repeaters. And this is typically done in analog fashion. So the signals are analog. However, in the recent past, something called digital FM modes has come into play, where the signal is not transmitted in analog fashion, but it's transmitted in digital mode. And this is found on VHF and UHF. And the benefit of digital modes is it not only transmits voice, but it can also transmit data. And another benefit of digital modes is that there's really no static in the background. The Digital modes also have the ability to be linked through gateways for long-distance communication. So something you really can't do through an analog repeater. You can't talk to somebody from, let's say you're in New York. You can't talk to your friend on your VHF or UHF repeater in California if it's an analog repeater. If it's a repeater that's running a digital mode, you can transmit to your local repeater, and that repeater will relay your message through the internet by use of a gateway connected to the repeater destination, maybe in California, and then retransmit your signal to your friend in California. So you can be sitting in in a park on an HT in your home location of New York and key up your transceiver and transmit to the repeater and talk to your friend who's sitting on the beach in California on their digital receiver and using their HT. So that's the benefit of FM digital voice modes. You can also join things that are called talk groups or rooms, where you can talk to other hams of a common interest. You can communicate, again, radio to radio or radio to repeater. So you can communicate directly from your HT to a mobile station through digital modes, or you can communicate with your HT or mobile rig to a repeater, and the repeater will retransmit your digital signal as to another station. Or you can connect through gateways or a hotspot in your home by having your HT or mobile hooked up to a hotspot in your house that's connected up to the internet, and you can talk to other people across the world or the country by utilizing that hotspot. The digital modes are beneficial in that it is almost all or nothing. So it doesn't fade like an analog signal does with increasing distance. You're essentially going to fall off a audio cliff per se. If you transmit and you get within maybe a mile outside of the distance of that digital repeater, your signal is just going to fall off. It's not going to slowly fade away. The one disadvantage of FM digital voice modes is that they can sound a little bit robotic or synthetic and not as warm and natural sounding as an analog voice signal. Digital voice modes for FM are also varied depending on what type of radio you have. So if you have an ICOM, their digital FM mode is called D-Star. If you have Yaesu, Yaesu has a mode called System Fusion, and there's yet another mode called DMR, or Digital Mobile Radio. So these aren't necessarily interoperable, so you can't communicate with an ICOM radio to a Yaesu radio with D-Star to System Fusion. You need to be communicating on the same digital mode. So you got to communicate ICOM D-Star to D-Star, or System Fusion to System Fusion, or digital mobile radio DMR to a DMR radio. DMR has both commercial applications and amateur applications, so there are more DMR radios out there. DMR radios can be Motorola, Anytone, and other radios, while again, ICOM has D-Star and Yaesu has System Fusion. So that's going to wrap it up for today's presentation. We hope you liked the information on the introduction on various digital modes, and that this will encourage you to go on and utilize some of the digital modes in your amateur radio career. Thanks again, and if you feel like supporting our YouTube channel, please go to radiosignals.org and click on the Support Us link. Thanks again, and we'll see you next time. 73.